friends and good afternoon. Welcome to our next session of 3 hinged arches. We shall solve one more numerical for finding out reactions and bending moment. A numerical which is very much similar to previous session. I have changed the loading, I have kept span same, and I have changed distance of point load from support A as well as central rise. Okay, so let us start. We have to find out the same, that is reactions, and we have to locate points of maximum bending moment. Okay, so to start with, we will consider this given arch as simply supported beam, and then we shall find vertical reactions. Okay, so this is our 4 kilonewton point load at 4 meter from A, and we will get vertical reactions from this VA and VB, correct? Remaining distance is 16 meter. So summation fx is equal to 0 for the arches. It is going to give us HA is equal to HB, correct? Summation fy is equal to 0. It is going to give us VA plus VB. It is equal to 4. Third condition, summation of movement about A or B is equal to 0. From this, minus VB into 4 plus 4 into 4 is equal to 0. So VB is equal to how much? 16 upon 20. So it is 0.8. VB is 0.8 kilonewton. Okay, I'll write here 0.8. So this is VA. From this equation, 4 minus 0.8 is 3.2 kilonewton. Correct? So two reactions are over. Now we have to find horizontal reactions. So we will consider free body diagram of CB part of the arch. So here is our B, this is HB, VB is 0.8 kilonewton. Here is crown C. So how much is this distance? 10 meter, correct? And vertical is 4 meter, it is given, central rise. So for this free body diagram, we will apply summation of moment about C is equal to 0. So we will get minus 0.8 into 10 plus HB into 4 is equal to 0. So from this, HB is how much? 8 upon 4. 0.8 into 10 is 8. 8 upon 4 is 2. So HB or HA, it is equal to 2 kilonewton, correct? Now we will find bending moment on point D, correct? This is equal to, as per yesterday's discussion, that is previous session's discussion, beam moment minus H into Y. So what is beam moment on D? 3.2 into 4, correct? Minus H. H is 2 into Y. What is Y? We want YD, this ordinate. So what is YD? 4YC upon L square x into L minus x. Substitute all the relevant values. So 4 into 4 upon 20 square into x is 4 into 20 minus 4. So it is 4 cube 4 into 4 into 4 into 16 upon 20 square, 2.56 meter. Correct? 2.56 meter. So bending moment at D. Now I will rub this. It is equal to 3.2 into 4 minus 2 times 2.56. So this value 3.2 into 4 minus 2 into 2.56. It is 7.68 kilonewton meter. So I will write here the value of BMD or bending moment value 7.68 kilonewton meter. So we shall say this is point C, D, crown is C here. So this is value 7.68 kilonewton meter. 0 on C and 0 then continue up to B. Okay. So we have found this maximum positive value. Now we have to get maximum negative value. So we will draw a free body diagram for C to B. Or here itself we can show section at a distance x from support B. So this is the free body diagram for CB arch. We have considered a section at a distance x from B, and we will now write down equation for bending moment at this section. Bending moment at x is equal to 0.8 into x minus 2 into y. What is y? 4 yc upon L square x into L minus x. So 4 into 4 upon 20 square x into L minus x. So this L is 20. So we will substitute L as 20 and recalculate this. 4 into 4 upon 20 square. It is 0.04 into x into 20. So 0.04 into 20, 0.8 into x minus now this value into x. So this ratio is 0.04 into x into x. So 0.04 x square, correct? So this is y. Now we will substitute back this value of y in equation of bending moment at x. So 0.08 x minus 2 times y is this much, 0.8 x minus 0.04 x square. Okay, Let us solve this, simplify this. So 2 into 0.8 is 1.6 x plus 2 into 0.04 is 0.08 x square. So 0.08 minus 1.6 is 1.52. So minus 1.52 x plus 0.08 x square. Correct? This is bending moment at x. Now differentiate this and equate it to 0. So minus 1.52 plus 0.08 into 2 is 0.16 x. So if you solve this, you will get x as 1.52 upon 0.16. The ratio is 9.5 meters. X is 9.5 meters. Okay. So now we will substitute x is equal to 9.5 meters in this equation. So let us calculate this. So bending moment at x is equal to 9.5 meters. It is equal to how much? Minus 1.52 into 9.5 plus 0.08 into 1.5 square. So value is minus 14.26 kilonewton meter. So it is somewhere here. This value is 14.26 kilonewton meter. So maximum positive value 7.68, maximum negative 14.26. Okay. Thank you. Hello friends. Now we will look into a new concept in 3 hinged arches. Here I have drawn an arch A, C, B. Okay. C is the crown, A and B are the supports. Supports are at same level. Now between A and C there is one load acting W1, which is on point D. Now what I have done is I have considered all forces from A to D vertically, VA, W1. Now on D, what I have done is I have found out what is shear force, net shear force on point D. How much is that? VA, if you consider AD part only and take vertical summation of vertical forces on left hand side of section, you will get VA minus W1. Correct? This is net shear force. Let us say this is VD, net shear force on point D. I have shown here. Okay. Then HD. So if you get summation fx from this, what you will get is HD is equal to HA. Correct? So these two horizontal vertical reactions I have shown on point D. Now on point D I have drawn a tangent. Okay. So this is tangent whose inclination with horizontal is theta. The angle of this tangent with horizontal is theta. What I am going to do now is I am going to resolve these two reactions. Correct? So we need two components in this, radial and tangent shear. Okay, because the plane is or the diagram is curved. Okay, So if you resolve this component into its two perpendicular directions, one will be parallel to tangent, another will be normal to tangent, correct? Similarly, this HD will also have two components, one will be normal to that tangent, correct, and another will be parallel to the tangent. So we have these totally four components, two of VD, two of HD. So this component will be sine component. So this is VD sine theta, this is VD cos theta, and here this will be HD sine theta, this is HD cos theta. Okay, so these are parallel to tangent, these are normal to tangent. So in this we can define now two terms or two concepts mathematically as normal thrust will be parallel to tangent, summation of reactions, summation of components of reactions acting parallel to the tangent. So this is HD cos theta plus VD sin theta. These two components are acting down the plane, we will assume them to be positive. Okay, and second concept is radial shear. This is equal to HD sin theta minus VD cos theta. So the component which is going up the plane we will assume positive, which is down the plane we will assume negative. That is the concept of normal thrust, radial shear. Okay, so these two are the additional actions which are getting induced in the arches apart from shear force and bending moment, correct? So in the next numericals we will find out how to calculate these two more terms apart from reactions, bending moments, and then these two, normal thrust, radial shear. Okay, thank you.